Hello, this is our circuit for simulation. We will show that the output of an inverting summing operational amplifier is equal to the negative of the ratio of the value of the feedback resistor to the value of the input resistance, where R1 equals R2 equals R3, multiplied by the algebraic sum of the individual voltage sources. In formula, V out is equals to negative Rf over R multiplied by the quantity V in 1 plus V in 2 plus V in 3. V in 1 has a value of 0.5 volts peak. V in 2 the same, 0.5 volts peak, and V in 3 has a value of 1 volt peak. Our simulation software needs an RMS or root mean square value for its input voltage. So we need to convert 0.5 volts peak to its RMS or root mean square value. This can be done by using the formula VRMS is equals to 0.707 times volts peak. So for V in 1 and V in 2, their RMS values are 0.707 times 0.5, which is equals to 0.3535 volts RMS. So 0.3535 volts. For V in 3, VRMS is equals to 0.707 times 1, which is equals to 0.707 volts RMS. Current I1 flows through R1. I2 flows through R2, while current I3 flows through R3. The current that flows to the inverting input of the op-amp is equals to 0, and also 0 for the current that flows into the non-inverting input. The non-inverting input is at ground potential, which is our voltage reference, and is equal to 0. Therefore, the potential difference between the inverting and the non-inverting terminals of the op-amp is equal to 0. Now, since no current flows into the op-amp terminals, the current through RF, which is IF, will be the sum of I1 plus I2 plus I3. Measuring V in 1 with our oscilloscope will show its amplitude to be equal to 0.5 volts peak. So the peak value is equals to 0.5 volts because 1 division multiplied by 500 millivolts or 0.5 volts is equals to 0.5 volt. Measuring V in 2 will show the same value. Measured value is equals to 0.5 volts. Now for the final measurement of the output, you will see that before that we will measure first the input voltage V in 3. So V in 3 measures 1 volt. There are two divisions, and the setting is 500 millivolt per division, so therefore the value is 1 volt or 1000 millivolts. For the final measurement, at the output, you will see that the oscilloscope will display its value to be equal to 6 volts peak. We connect our output terminal to our oscilloscope. So you will see that the output has a peak value of, there are 3 divisions multiplied by the settings channel A, 2 volts per division. So the output is 2 times 3 division. We have 6 volts peak. Therefore, the simulation of the inverting summing amplifier circuit confirms the formula that the output of the inverting summing operational amplifier is equal to the negative the ratio of the value of the feedback resistor to the value of the input resistance, where R1 is equals to R2 is equals to R3, then multiplied by the algebraic sum of the individual voltage sources. Thank you for watching.